Hello everyone. Today we are going to let have our fifth lecture on electrical machines. Today we will discuss about classification with effect of equations. We will discuss various equations which help us in numerical analysis. So starting these are same in both cases, generator and motor. However, the equations are not same. So firstly we will discuss about generator and then we discuss about motor. For the first case, let this is a DC machine. It is divided in two parts. Let the DC machine be generator or motor, but we are discussing the main parts, main distribution. So firstly we are neglecting whether the machine is DC generator or motor. We will discuss about just DC machine. So there can be two types of DC machine. The first one is permanent magnet DC machine. So the permanent magnet is the one where the field poles have no field winding. These are just simply permanent magnet or say magnetic poles. They are not energized by the supply in any case. They have their own magnetic flux which work. So the second one is excitation type or say electromagnetic magnetic DC machine. Electromagnetic DC machine is the one which have field winding. Like when we connect field winding, when we connect supply to the field winding which are located on the field poles, then the flux is generated in the field poles and then the armature conductor cuts that. So the electromagnetic DC machine is further divided into two parts. First one is separately excited. The separately excited DC machine is one where the separation of supply or excitation is given to field winding and armature winding. Like the field winding is get excited from a different source and the armature winding is get excited from different source, then the flux is cut by the armature conductors and then the machine starts rotating. And the other one is self excited. A single source is used to excite the field winding as well as armature winding of DC machine. So the self-excited DC machine is classified into three parts. First one is DC shunt machine. In this machine, the field winding is connected in parallel with armature winding. The second one is DC series machine. In this machine, the armature winding is connected in series with the field winding. And the third one is DC compound. machine. In this machine, the armature winding and the field winding are connected in series and parallel both combination. Like the field winding which is connected in parallel with armature winding is known as shunt field, and the field winding connected in series with field armature winding is known as series field. Further, the DC compound machine is also divided into two parts. First one is long shunt. This consists of the shunt field connected in field parallel with both the series field and armature field, or I'll say the series combination of series field and armature winding is have having the shunt field in parallel. Shunt field DC compound machine, and the other one is short shunt DC compound machine. In this machine, the shunt field winding is connected in parallel with armature winding only. So, the basic machines which we will discuss in our course are electromagnetic DC machines, self-excited DC machines, DC shunt, series, compound, long shunt and short shunt. However, the permanent magnet DC machine are much easier, so and separately excited DC machine are less used and took less in applications. So we will not discuss them, or the theoretical part we covered about them is enough to understand the machine. However, we will discuss the separately excited DC machine later. So we will cover both the cases, like starting from here. First one is DC shunt machine. Suppose for a generator, this is the armature, this is the field winding. When the field winding is connected in shunt, the resistance of shunt field winding is much way higher than the armature winding. The reason is so that the less current goes or flow through the field winding that is required for generation of flux or magnetizing the coil. These are the terminals. This is armature having resistance Ra. The current flowing through armature is Ia. These are brushes. So the brush drop Vb, and this is armature where EMF is generated Eg. Here the current through field winding is Is. The resistance is IRSH, and the voltage at terminals is V. So for a generator, the equation will be the generated EMF Eg is equal to the loss is Ia Ra minus Vb फिर माइनस नहीं प्लस आएगा, प्लस वी बी प्लस वी। So the equation will be the terminal voltage is equal to generated voltage minus IARA minus VB. We have to remember this equation because it's the general equation for finding the voltage, the generated EMF, the armature current, the armature resistance, or the burst drop in any case. For a motor, the circuit diagram will be: here's a source V, the armature with brushes, the field winding, EG, RA, IA, IS, RS, VB. So for a motor the equation will be V equals to IA RA plus VB plus EG. The generated EMF will be V minus IARA minus VB. So this is the all part we have discussed today. In the upcoming lecture we will discuss the rest part. We will discuss about DC series machine, DC compound machine. We will discuss about them in detail, and for the next lecture, this is the plan for next 2 or 3 lectures. This is our lecture 5.2. Today is our lecture 5.1, and for the 6th lecture we will try some numerical portion in which we will discuss some numericals regarding these equations. We will discuss about EMF equation. We will do numerical on EMF equation and DC machines, that part. So that's all for today. Thank you everyone.